All right, everyone, get ready, because today we're going to be looking at something truly revolutionary, light-powered memory. That's 100 times faster than what we're using today. And you know how we're always trying to get like faster computers, better phones, just anything that can process information more quickly. Well, we're hitting a wall. With the technology that we have, chips can only get so small, and they generate a ton of heat. It's like trying to cram more and more stuff into a tiny little room. And eventually things get way too toasty and it just doesn't work anymore. But what if we use something completely different, something that was faster and cooler, literally? That's where photonics comes in, which is the science of using light to process information. Just think about it. Light travels way faster than electrons do, and it generates way less heat. So how does this actually work? Well, researchers have been looking into something called magneto-optical memory, which makes use of a really special material. It's called cerium-substituted helium iron garnet, or CNALD.YIG for short. Now, that C.YIG is really amazing because when you apply a magnetic field, its optical properties change. Imagine a tiny little light switch that you can flip on and off billions of times without it wearing out, just by using magnets. That's essentially what's happening here. And these magnetic fields can actually be used to control the polarization of light passing through the Hc.YIG. And for those of you who don't know, polarization is basically the direction that light waves vibrate. So by controlling these magnetic fields, we can actually encode data into the light itself. It's kind of like using different polarizations to represent the zeros and ones in binary code, only much, much faster. This means that we can actually read and write data at unbelievable speeds. We're talking a fraction of a nanosecond. Being able to access information on your hard drive in less time than it takes you to blink. That's how fast we're talking about. And it's not just speed either. This technology is also incredibly energy efficient. And because we're using light instead of electricity, this magneto-optical memory generates much less heat. You remember how we talked about how computer chips today get so hot? That's a big problem. And that's why our devices need those like big, bulky cooling systems. With photonics, we could potentially pack components much closer together without having to worry about them overheating. So imagine slimmer phones, lighter laptops, and data centers that don't need massive cooling infrastructure. This could be a huge step forward for energy efficiency and sustainability, which are becoming more and more important. And the benefits, they don't stop there. This technology is also incredibly durable. Researchers have found that these new magneto-optical memories can be rewritten over 2 billion times. Right? That's like almost unlimited. Think about that. A hard drive that basically never wears out. You don't have to worry about losing data or replacing components. Now let's talk about the bigger picture. What can this technology actually mean for the future? Well, we already talked about some potential applications like AI and machine learning. Imagine AI algorithms that can process information super fast, leading to new discoveries in fields like personalized medicine, self-driving cars, and even climate modeling. But it goes beyond that. Think about medical devices that can analyze huge amounts of data right away, giving doctors faster and more accurate diagnoses. Or imagine weather forecasting models that can predict storms and natural disasters really accurately, giving us more time to prepare and possibly even saving lives. And of course, let's not forget about scientific research. We can run complex simulations that help us understand the secrets of the universe at speeds we never even thought were possible, from learning about the origins of the cosmos to developing life-saving drugs. The possibilities are really mind-blowing. But there's one more thing about this technology that I think it's super interesting. It has to do with how we design computers themselves. Our computers have different components for processing and memory. It's like having a library, which is your memory. That's miles away from your reading room. That's the processor. And every time that you need information, you have to go on this long trip back and forth. With this new magneto-optical memory, we can actually do the processing right there inside the memory. And this is actually called in-memory computing. And it could totally change the way that we think about computer architecture. And if you think about those AI applications that we're talking about, like right now, training a large language model or analyzing a complex data set, that takes a lot of energy and a lot of time because of all that data moving back and forth between the processor and memory. But with in-memory computing, powered by light, those processes could become way faster and much more energy efficient. It's kind of like switching out a horse-drawn carriage for a high-speed train. And so the implications for fields like scientific research, medical diagnostics, and financial modeling, those are huge. Like imagine scientists being able to run or Doctors being able to personalize treatment plans based on like a patient's entire genetic history and doing that instantly. I know what you're thinking, this sounds pretty futuristic. And you're right, this technology, it's still in its early stages. There are definitely some challenges ahead, like we have to figure out how to scale up production and how to integrate this new type of memory with our existing system. The researchers are optimistic. They think that in the next few years, we might start seeing this technology show up in more specialized applications, like high-performance computing and data centers. Who knows, maybe someday soon, we'll all have these like light-powered smartphones. They're not just 100 times faster, but can also run for days on just a single charge. It's a future where the power of light could unlock some incredible new possibilities and make our lives easier, healthier, and more connected than ever before. It's definitely a future worth getting excited about.